Okay, girls, this is page 14 of the Congruence booklet. We're looking at examples 1 and 2 on this page. I'd like you to do part A, where you're proving that the triangles are congruent. If you can go down to there, prove that triangles are congruent. Pause the video while you do that and then restart. Okay, girls, hopefully you've had enough time for that. So let's look at the first line. Prove that triangle ABC. So triangle ABC is congruent to triangle EDC. All right, we start our proof by identifying our triangles. So in triangle ABC and triangle EDC, we know that AC equals CE, and the reason is? Yeah, and look, it is given, and we could also write that AE and like that BD bisects AE. But it is given because the markings are on the diagram, but they do tell us that AE and BD bisect each other at C. Now, if you want to say that AC equals CE, that would be because BD bisects AE. Does that make sense? BD cuts AE in half. That's what bisects mean. Look, it is marked on the diagram, but because it says it up here, I'm going to say that AC equals CE because BD bisects AE. We've got also here that angle ACB, this angle in here, is equal to angle DCE. And what's the reason for that, girls? Vertically opposite angles. I do not want to see any abbreviations. So we've got vertically opposite angles. The only abbreviation that I'd like to see is for the symbol angle, okay? I don't want to see vert-op angles, all right, because you will get a mark deducted. All right, we know that BC equals CD. It is marked on the diagram, but what is the reason that's given up here? Would you say that AE bisects BD, or would you say the other way? We're on page 14. Why does BC equal CD? Because AE bisects BD. So, girls, so everything is now marked on the diagram that those two sides are equal, these two sides are equal, and the angles are equal. So what's the reason that triangle ABC is congruent to triangle EDC? It's SAS. Now the next part of the question is where it's a little bit different. In part B, we have to show that AB is parallel to DE. Now, there are 3 ways that you can prove that 2 lines are parallel. Remember, there's 3 rules that are associated with parallel lines. So if I've got parallel lines, I'm just going to draw them over here. So if I've got parallel lines, we know that, for example, alternate angles are equal, right? We also know that corresponding angles are equal. So the alternate angles are those Z angles, they're marked with arcs. The corresponding angles are like those F angles, they're marked with dots, all right? So we're actually doing the converse or the opposite of these theorems. The way that you learn it in year 8, it says if 2 lines are parallel, then alternate angles are equal or corresponding angles are equal. And the other one is that co-interior angles, like for example, angle A plus B is 180, that co-interior angles add up to 180. Now that's one of the 3 things that we can do with parallel lines. But we're actually doing this backwards. We don't know that they're parallel lines. We're trying to prove that the lines are parallel. So what we do, we look at the 2 triangles up here that we've got, and we've just proven that they're congruent. So what I want to do, to prove that AB is parallel to DE, I need to prove either that alternate angles are equal. So the normal way we speak about parallel lines is the following. If 2 lines are parallel, then alternate angles are equal. Now the converse theorem, or the opposite of that, is if alternate angles are equal, so I'll just do that down here. So that's the normal theorem. The converse theorem is, let's say I've got those 2 lines here, line 1 and 2, and I don't know that they're parallel. I need everyone listening to this. If this alternate angle is equal to that alternate angle, like let's say they're both 70 degrees, then those 2 lines have to be parallel. That's what we call the converse theorem, or the opposite way of stating the theorem. So we say if alternate angles are equal, then the 2 lines there are parallel. Normally you're used to saying if these 2 lines are parallel, then alternate angles are equal. we're doing it the opposite way. If alternate angles are equal, then the lines, these two lines, have to be parallel. And that's what we're doing here. So angle ABC, this one up here, what's its matching angle? It's opposite the side with the double dash, or the arc is between the plane side and the single dash side. Can you see that? So its matching angle would be between the plain unmarked side and the single dash side, or you could say it's opposite the double dash side. So angle ABC is equal to angle CDE, and the reason is not that it's not that they are alternate, but they are corresponding angles of congruent triangles. The reason I'm saying that that angle equals that one is that I've proven that the two triangles are congruent, and those are the matching or corresponding angles in those congruent triangles. Yes, then we say but or and that angle ABC and CDE are also alternate angles. Now what we've just shown is that those two angles are alternate.
How did we show they're corresponding?
Well, let's pretend if I just said angle ABC equals which one? Isn't it this one? Because I've proven that the two triangles are congruent. This angle here is opposite the double dash side. So this angle down here is opposite the double dash side. Girls, this is corresponding or matching, not corresponding as in parallel lines. Why don't you put, instead of, if you're going to get confused, I want you to put that those two angles are the matching, that they're the matching angles of congruent triangles, or the corresponding. Girls, corresponding with parallel lines is different to corresponding, meaning that this relates to that. When I say corresponding angles of congruent triangles, I mean which, I'm saying, all right, I've got this arc marked up here, or this angle marked up here. What's its matching angle down here? Which one's in the same position? Well, it's this angle here at D that's in the same position. That's what we mean by corresponding angles of congruent triangles. It's different to corresponding angles on parallel lines. Okay? So you might, instead of wanting to use that word corresponding here, you'll say that they're matching angles of congruent triangles, but then we say, wait a sec, these two angles also form that Z angle, they're alternate. So we've just shown that alternate angles are equal, that those two angles are alternate, but they're the same size, they're equal to each other. So therefore we can say, well, AB must be parallel to DE because those two alternate angles that I found are equal. Now, I'm going to draw two lines just down here, for example, that are obviously not parallel, just watching. Now, this angle there is alternate with this dot, but do they look the same size? They're not the same size. Why? Because the lines aren't parallel. The only way that alternate angles will be equal, girls, alternate angles don't always have to be equal. They're only equal, alternate is a definition describing position from that side of the line to this side of the line. They're alternate angles, but they're not equal. Okay, so these are not equal. These angles are not equal because those lines are not parallel. But once the lines are parallel, then alternate angles will be equal. One sec. Do you get what I'm saying? Alternate describes the position. Alternate angles are only equal if these two lines are parallel. These two lines are not parallel, so these angles here are clearly not the same size. Okay? But if these lines here are parallel, they actually don't look parallel either. But if they were parallel, they would be the same size. Does that make sense? Bisect means cut in half. So they cut each other in half, different to science. Dissect the sheep's eye means to just cut it however you like. Mangulate it if you want. All right, girls, look, we are going to do another question like that parallel line one on the next page. Let's try another one down here. Now, hopefully you've already had a look at the first part of the question for the proof bit. I know that the girls that were here earlier have. So let's have a look at that. If you want, you can pause the video, prove that these two triangles here are congruent, that PQS is congruent to triangle RQS. That's the first part. Then in the second part, we've got to show that triangle PQR, the big one, is isosceles. Now, in all these proofs, all these examples from now on, the first step is to prove that the two triangles are congruent. Then the next step will always be, therefore, this angle equals that one, matching or corresponding angles of congruent triangles, or this side equals that side, corresponding sides of congruent triangles, and then there'll always be another line afterwards. Okay, so let's go. In triangle PQS and triangle RQS, angle PQS equals angle RQS. Reason, I know there's markings on the diagram, but read up here. QS bisects angle PQR, meaning that this line, see QS is a line or an interval, angle PQR. So QS cuts angle PQR in half. Okay, so the reason that those two angles are equal is that QS bisects angle PQR. Now, if it's an angle, you must put the angle symbol. If you don't put the angle symbol, it means you're talking about, it could be an interval, not an angle, okay? The next bit, angle QSP is equal to angle QSR, which is 90 degrees. Reason, QS is perpendicular to PR. Now, you might say, but Miss, the right angle symbol's only on one side. When we're told that QS is perpendicular to PR, it means that those two lines, when we're told that QS is perpendicular to PR, it means that those two intervals meet at right angles. You only need to put the right angle symbol on one side, all right? Okay, we also know that QS is a common side. So we've got the angle, we've got this. I'm going to put QS as a common side with a double dash. I can't use single dashes because they're already used down here. So if I did draw these two triangles separately, what do I have? I think I've got extra information. We didn't actually do this. QS bisects that angle. I don't know why these markings are here on the diagram. They shouldn't be there. We haven't spoken about that at all. So I want you to ignore those markings at the moment. Well, if you ignore those, ignore those two circles. I mean, I know that they are equal, but that's later. I don't know why it's marked on the diagram. So what would you use if you just use those? Remember, we've got this angle too. AAS. AAS. We haven't included this in our proof, have we? Have we said that PS equals SR? So you can't use it as one of your reasons. Does that make sense? Yeah. All right, so we've got QS is common, therefore triangle PQS is congruent to triangle RQS, and the reason is AAS. Just ignoring these at the moment because they're not mentioned at all in the question, and I haven't put them here. But you could have put them in your proof. Let's say you did put them in your proof. If you did put these two in your proof, what reason would you have done down here? But you would have had to have said PS equals RS. It would have been SAS. All right? Okay, now, you can't assume that these are equal down the bottom. The only time that PS will equal RS at the bottom is if it's an isosceles triangle or an equilateral triangle. Now, watch what I'm doing here. Girls, this is a scalene triangle. All three sides are different. I need everyone watching. All right, this is a scalene triangle. Just because I draw a line down from there and it might be perpendicular, you can see that that length there does not equal this length here. The only time that that length at the bottom will equal this one is if it's either an equilateral triangle or an isosceles triangle. In other words, these two sides have to be the same. So when those two sides are the same and I bring a line down from the apex down to the base, only if it's isosceles or equilateral will it bisect up here and will it bisect down there. All right? So it's only a special property of an equilateral triangle or an isosceles triangle. In other words, these two sides have to be the same. Equilateral triangle's got all three sides the same, but an equilateral triangle has everything that an isosceles triangle has and more. Yeah. See, because an isosceles triangle is two equal angles and two equal sides, but an equilateral triangle has more than that. It's got three equal angles and three equal sides. Yeah. So you could classify an equilateral triangle as an isosceles triangle plus extra information. It's just like a square is a rectangle, because a square has all the properties of a rectangle plus more. Okay? All right, girls. Now, so we've proven that those two triangles are congruent, and the next part is, see, we're trying to prove that this triangle here is isosceles, and what we're going to say is, well, side PQ equals side QR. Why? Once you've proven that those two triangles are congruent, why does PQ equal QR?
Corresponding sides of
Yeah,
congruent
because they're corresponding sides of congruent triangles. So therefore, triangle PQR is isosceles. Why is it isosceles? Because that triangle now has how many equal sides? You've just proven that PQ equals QR in this triangle. So why is triangle PQR isosceles? Because it has two equal sides. Now girls, when you're talking about isosceles triangle, I'd rather you say it's got two equal sides rather than two equal angles. All right? Because if you say two equal angles, then you've got to say, well, the sides opposite those equal angles are equal, therefore it's isosceles. All right? So do your isosceles triangle thing based on equal sides. Do you get that, girls? So we're doing the proof. Next step is, well, they're corresponding sides of congruent triangles. Because we've proven that these two are congruent, PQ is opposite the right angle, QR is opposite the right angle, so they're corresponding or matching sides of congruent triangles. Now looking at the big triangle, PQ equals QR, and we've got two equal sides. That's why PQR is isosceles. O is the centre of the circle and OM is perpendicular to EF, and because of OM being perpendicular to EF, you'll be able to say that angle OMF equals angle OME, which is 90, all right? Now, angle OME equals OMF, which is 90 degrees. Reason? OM is perpendicular to EF. Now, girls, there are a few shorthand things that you can use in maths reasoning. One of them is the angle symbol, all right? The triangle symbol, parallel, perpendicular, equals. Wait a sec.
You can do the three.
Girls, congruent. Excuse me, ladies. These are the symbols you can use. Angle, triangle, parallel, perpendicular, equals, congruent. Of course, there's therefore and things like that. But I don't want to see anything else. Vertically opposite, you write the whole thing. Okay? Now, those two angles are equal, and I'd put the other side now that you've stated it, because OM is perpendicular to EF. OE equals OF. Why? Why? It's a circle. So equal radii of circle. So we've got equal radii of circle, and in these two triangles, OM is a what? Common side, or you can write OM equals OM common side. So girls, I've marked on the diagram what we've got, therefore OEM is congruent to triangle OFM. What's the reason? R, H, S. Girls, it is not SAS. You try SAS, S, the angle would have to be up there. And we don't know that those angles are equal. So it's RHS. Okay. Next part of the question. We are trying to prove that OM bisects angle EOF. So what you're trying to prove is that that angle up there equals that angle up here. If OM bisects angle EOF,
Corresponding angles.
so we say angle EOM is equals angle FOM, because they are, if you look at those two triangles that are congruent, that we've just proven are congruent, they are in the same position. So they are corresponding
Angles of congruent triangles.
or matching angles. Do you know what I mean? Corresponding angles of congruent triangles.
Monsieur Rivera.
So therefore, OM must bisect angle EOF, because it's basically that line has made two equal angles there, so it's therefore cut it in half. Okay? All right, girls. I don't think so. It is? Okay. Example 4, girls. If you could please try the first part of this question where we are proving that triangle YXW is congruent to triangle YZW. You are told here that xy equals yz, and you were also told that yw bisects xz. So if we can start on that proof. So we've got xy equals yz. What's the reason? See how it's written up there? It's given. Okay, next. Why does xw equals wz? Why? Because yw bisects xz. What else have we got? That. I've got two sides. Let's try for SSS. What have we got? YW is a common side, or you could write YW equals YW, common side. So therefore, you can see I put 3 dashes there. Single dash, double dash, triple dash. Therefore, they're congruent by SSS. Next part of the question, you have to hence show that YW is perpendicular to XZ. Now, this is one of the harder ones, girls. It's a little bit different. Again, girls, notice after these proofs, every single first step is that they're either corresponding angles or corresponding sides of congruent triangles. That's always our first thing. So I've got that angle YWX equals angle YWZ. Why? Because they are corresponding or matching angles of congruent triangles. Corresponding angles of congruent triangles. But, so I've got that they're equal, girls, but angle YWX plus angle YWZ is equal to 180. Why am I saying that they're equal to 180? Because they're on a straight line. So we say you can either write supplementary angles or angles on a straight line. And the straight line is XWZ. See how it passes through those? Girls, you know when you name an angle? You go from the vertex to the, you go from the end point to the vertex to the other end point. That angle, you could say the actual angle is XWZ.
Can't you just say XZ?
You could say straight, yeah, you could, but I like to put the vertex in the middle. Because a straight line does have a vertex in the middle. It's not an interval, okay? So therefore, if those two angles are equal and those two angles add up to 180, what do they have to be? 90. So they are. So therefore that angle there equals this angle, which is 180 divided by 2, which is 90 degrees. So we've just proven that these two angles are 90 degrees. Therefore we can say, can you see what we can say now? Therefore YW is perpendicular to XZ. All right, we're now going to page 16. Okay, we're now looking at page 16. We're doing exactly the same thing again. We're proving properties of special triangles and quadrilaterals using congruent triangles. So in this question here, we're told that ABC is an isosceles triangle in which AB equals AC. We're also told that AD is the bisector of angle BAC. You have to prove, now girls notice, the question is not saying to me to prove that the two triangles are congruent. It's telling me to prove that AD bisects BC and that angle B equals angle C. Now it's asking me to prove those things. It's not telling me to prove that the two triangles are congruent, but I'm telling you, you have to prove that the two triangles are congruent first. Because once you've proven that the two triangles are congruent, you can then say, once they're congruent, you can say, yes, that angle matches that one. This angle matches that one. They're corresponding sides of congruent triangles, for example. So girls, just because these questions aren't saying prove that the triangles are congruent, it doesn't, you still need to do it. It's the only way that you can prove that that angle in the end equals this one and that this side, for example, equals that. All right, so let's start with the proof. In triangle ABD and triangle ACD, we know that AB equals AC. Was it mentioned?
Yeah.
So it's given. We know that AD equals AD. Reason? Common side. Now, girls, I'll just tell you what I find a common error is in these questions. A common error is that people will look at this prove that AD bisects BC and they'll start saying that BD equals CD without even proving it. They'll start saying, well, angle B equals angle C. They're not telling you that angle B equals C. They're asking you to prove it. So you're not allowed to use that angle B equals C in the proof at all. You're only allowed to use what you've got here, okay? So you're not allowed to use that. We know that BD will eventually equal DC, but you can't tell me that now, all right? That's what you're trying to prove. So anything that you're trying to prove, don't tell me that it's true because I'll just mark it wrong, all right? You don't do it until you've proven that the triangles are congruent. We work with what we've got first. We know that that equals that. We know that this side is common. They have told us that AD is the bisector of angle BAC. So we can say that these two angles are equal. So angle BAD equals angle CAD. Reason, AD bisects angle BAC. Hence, so therefore, triangle ABD is congruent to triangle. Try and do it in the same order. What is it going to be? ACD. And what's the reason? We've got it all marked. We've got side, angle side, side, angle side, side, angle side. It's SAS. So we've done that. We've proven that the two triangles are congruent. So now we say, hence, now that they're congruent, they're identical, we can say, well, hence angle B is equal to angle C. Now, girls, notice, we normally like to name the angles using 3 letters. But this time we're not at B. I could never say angle A because, you know, there are actually 3 angles at angle A. There's angle BAD, there's angle DAC, and there's angle BAC. So you could never call angle A, angle A. But you could call angle B because there's no confusion about what the angle is. There's only one angle at B. Do you see that? So hence angle B equals angle C, and the reason is? Why do those two angles equal each other? I've just proven that the triangles are no. I've just proven that the two triangles are congruent, so they are corresponding angles of congruent triangles. You probably can't see that now. And also we know that BD equals what? What does BD equal? DC. Why do you know that those two are equal? I put triple dashes on those. Why are those two equal? BD equals CD, corresponding sides of congruent triangles. See, girls, once the two triangles are proven to be congruent, you then turn around and say, yep, that angle matches that one, that side matches that one. That's all you're allowed to do once you've proven that two things are congruent. Now, if that equals that, if BD equals CD, doesn't it mean that AD cuts it in half?
Yeah.
So now we say, therefore, AD bisects BC.
I just want to see if you could put it instead of
No, you must do these. So once you've proven that two triangles are congruent, these are automatically the next steps. You'll either say corresponding angles are equal, corresponding angles of congruent triangles are equal, or corresponding sides of congruent triangles are equal. Remember, when you've proven that two triangles are congruent, you've proven that they're identical. Remember, you only need 3 pieces of information to prove that they're congruent. So you've only proven maybe 2 sides and an angle, but you're now allowed to say, well, that other side that I didn't prove before, well, I know they're equal. That other angle that wasn't mentioned in the proof, I know they're equal now. Does that make sense? Yeah. To prove congruence, you only need 3 facts out of the 6. 6 meaning 3 sides of a triangle equal 3 sides of the other, and 3 angles equal 3 angles. That's what congruence means, that they're identical. But the proofs only require 3 pieces of information.
So does that mean if we weren't given stuff, like all our answers could be different?
Yes, everyone can come up with proving different ways, but I think in this one there was only one way to do it. All right?
So we're just doing triangles.
We're doing quadrilaterals on the next page, I think. Okay, girls, in this question, they've told us that ABC is an equilateral triangle. So automatically you know, tell me what you know about equilateral triangles. All sides are equal. What about the angles? So that's 60 down there, so's that, and this one up here would be 60, the big one, but don't mark it yet. They say that a line from the vertex A is joined to D, which happens to be the midpoint of BC. Prove that angle BAD is equal to angle CAD. Okay, girls, they haven't asked you to prove that the triangles are congruent, but you're going to have to do that first. And once you've proven that the triangles are congruent, you can then say, well, angle BAD equals angle CAD, matching angles of congruent triangles, therefore I've proven it. So please, you first must prove that triangle ABD is congruent to triangle ACD. Okay, let's go. In triangle ABD and triangle ACD, we know that AB equals AC. Now, that's not given. How do you know that? No. Why does that side equal that side? It's got nothing. Yeah, it's equal sides
We also say that there were.
of well, it isn't. Does it say here that AB equals AC? No, it doesn't say it. But the reason is it's an equilateral triangle. So we've got equal sides of equilateral triangle. That's the reason. In some questions like this one up here, it says AB equals AC. That's given. Here, I know they've marked it on the diagram, but they're saying that ABC is an equilateral triangle. So you can say, well, AB equals AC because they are equal sides of an equilateral triangle. Or you just say equilateral triangle has all sides equal. I don't care what you write, as long as you're putting equilateral triangle, equal sides. All right? Doesn't have to be the same way exactly that someone else writes it. Okay? Now, BD equals what? CD or DC. How do you know that? How do you know? Because D is the midpoint. D, girls, if D is the midpoint of BC, no, it's not that AD, it doesn't say AD by 6, BC. It says that D is the midpoint of BC. So the reason is that D is the midpoint of BC. Midpoint is the halfway mark. So if it's the halfway mark, then BD equals CD. Does that make sense? I can't see AD by 6 BC here. It's not written. It does, but they didn't write that. Okay, they just said that D is the midpoint, and that's what you write. Angle ABD is equal to angle, so this angle, what do you think it's equal to? Yeah, equals angle ACD equals 60 degrees. Why are you writing that? Well, I wouldn't say isosceles triangle. We know it's an equilateral triangle. Angles in it. No. Why? Why is that 60? Yeah, all angles of an equilateral triangle are 60 degrees. So our reason is that angles in an equilateral triangle are equal to 60 degrees. Are we okay with that? Equilateral triangle, girls. So girls, the reason that those two angles are 60, so is this one, but I'm not mentioning it here, is that all angles in an equilateral triangle are 60 degrees. D is congruent to triangle A. You've got to do it in the same order, and I've got side, angle, side, side, angle, side. Now, the question was to prove that angle BAD, this one up here, is equal to this one. So we're trying to prove that that angle up there equals angle CAD. And why do they equal each other? Why does this angle up there in red equal that one now? Corresponding or matching angles, corresponding angles of congruent triangles. Okay. Now we're going to go over the page to questions, over the page to page 17. It's the last page of the booklet. In the question 3 on page 17, we've only got 2 more questions to go. In this first question, we have to prove, actually girls, this is the question here, over here. This is my working out. So the question might just be, you may just get the question, that prove that opposite sides and angles of a parallelogram are equal. So that's all you'll see, what's there. You won't see this, not going to guide it. I won't guide it in a level 5. I'll probably guide it in lower levels, all right? So how are you going to prove that opposite sides and angles of a parallelogram are equal? Now, the way you do it is to prove that the triangles are congruent. See, once you've proven that triangle ABD is congruent to triangle CBD, can't you say, well, that AD equals BC, corresponding sides of congruent triangles? You can say that AB equals DC, corresponding sides of congruent triangles. And to prove that opposite angles are equal, we can say that this angle equals that one, corresponding angles of congruent triangles. So if you, in this topic, if it's asking you to prove that opposite sides, or like any properties of a parallelogram, or any properties of a square or a rectangle, first prove that triangles are congruent first. Because then you say, well, that matches with that matches with that, those angles are the same angles, and that's how you prove all the properties. So let's start. This is really important. You need to first prove that triangle ABD is congruent to triangle CDB. So in these two triangles, BD equals,
BD, common side.
and it's common, BD equals BD, and it's a common side.